In this video I will show how to find the hydrostatic force exerted by a liquid on a surface submerged in the liquid. So the formula that we're going to use is the following. So to find the force, we're going to integrate from A to B, where A to B represents the levels, the lowest and the highest level of the surface. And the integrand is rho g. Rho is the density, g is gravitational constant, times h of x. H of x is the expression that represents the depth of some arbitrary selected thin layer of area. W will represent the width of that layer as a function of x dx. So basically on the surface we're going to pick some arbitrary level x, and wx will be the width and h of x will be the depth. In our case we have a cylindrical tank which is half full. We are going to assign the only coordinate axis to point down and start at the top of the tank, and let's pick some arbitrary level x, and then h of x will be the depth, which in this coordinate plane can be expressed as x minus x minus 5. And the width of this strip can be then expressed using the geometry. We can find this expression by applying the Pythagorean theorem, which will be square root of 5 squared minus x minus 5 squared. So width will be 2 times that. So the integral that we are setting up is the following. We integrate from 5 to 10, and we're integrating 820, which is raw, times 9.8, which is g, times x minus 5, which is the expression for the depth of the layer with the x coordinate x, and we have a square root of 25 minus x minus 5 squared dx. And we're going to do this integral by substitution. So we're gonna let t be equal to x minus 5, then dt is exactly dx, and then we have the new limits of integration going from 0 to 5. So the integral is now from 0 to 5, 820 times 9.8. Here I'm missing a factor of 2. Now instead of x minus 5 we put t, and instead of the radical we put 25 minus t squared inside of the radical dt. Now this suggests the following substitution: t equals sine theta, in which dt will be equal to 5 cosine theta d theta, so that square root of 25 minus t squared will be equal to 5 cosine theta. The limits of integration in this substitution will change to when t is 0, theta must be 0, and when t is 5t, theta must be pi over 2. So we get the following integral, in which I'm going to first factor out all the coefficients, and then we have the following integral. T is 5 sine theta, square root of 25, square root of 25 minus t squared is 5 cosine theta, dt is 5 cosine theta d theta. So we get 820 times 9.8 times 2 times 5 cube, integral from 0 to pi over 2 sine theta cosine squared theta d theta. And the derivative of sine theta cosine squared theta is negative cosine cube theta over 3. That is easy to verify by just differentiating this negative cosine cube theta over 3, which we evaluate from 0 to pi over 2. So we get 820 times 9.8 times 2 times 5 cube. Cosine of pi over 2 is 0, and at 0 it is 1. So taking away negative 1/3 from 0 gives us positive 1/3. So the final answer would be 1/3 820 times 9.8 times 2 times 5 cube newtons. So this is the final answer, which can be easily computed using a calculator.